second longer. But are there any questions at all that you guys may have on anything that we've covered so far? Oh, can everybody still hear me? Got to make sure y'all can still hear me. Okay, got to make sure y'all can still hear me. Not a problem. I get worried whenever I hear a long silence. It's awkward silence. And we're back at 10:50. So, are there any questions at all? Yeah, the long awkward silence always bothers me whenever I don't hear anybody in the background.
I totally understand, but I think I'm good from what you've done so far. Everybody else?
Awesome. Let's see. For C, can you explain sine -1 again, how you got the x? For which one on C again? We were just waiting on you, Dr. Hernandez, and I apologize. I was
That's okay. Go ahead.
bringing them back in. And 30C, so for 30 part C, can I explain how I got the x? And so for 30 part C, how did I get the x? Oh, for the inverse sine. Okay, yeah. So I'm going to share with them one last time this so I can show them how I got the inverse sine. So what I did is I know if I set, and I did not do this, I kind of skipped a step. I was setting that derivative equal to 0. Negative pi times the sine of pi x is equal to 0. So I divided both sides by negative pi, and I get that sine of pi x equals to 0. And in order to solve this, I took the inverse sine of both sides and the inverse sine of 0. And the inverse sine of 0 is 0. And that's where I got this. And then I divided again by pi, and that's how I got that x was 0. So that's how I did that one. And that's a great question. Thank you very much for asking that. I did kind of gloss over that. But here we go. This is now for Dr. Hernandez. It's your turn to shine, sir, and I'll feed you the questions.
Okay, sounds good. Again, guys, I posted a link to a survey that we would like you to please take a few minutes and complete. I am going to put it again on the chat right now. It should be there on the chat now. It's a link for you to fill out a survey. It only takes a few minutes, so please do that at some point. We're going to move on to chapter 4 and start talking about problems regarding integration from chapter 4. Those on chapter 4, if you look at the review problems, start with number 32 and they go all the way to 39. And some of them have multiple parts as usual. So questions from 32 to 39 are questions on chapter 4. And Professor, I would like you to, if you don't mind, keep an eye on the chat and let me know what questions come up. If not, I'll just choose some good ones and I'll work them out.
Yes, sir, Dr. Hernandez. I'll be looking at the chat here. Let's see, what do we got, guys? What do y'all want to see? No requests just yet.
I'll break the ice. Let's see. We're talking about 32. Okay, how about if we do maybe 32, 32D perhaps, or
Yeah, I think nobody's asked any questions. Oh, 33C. Sorry about that, Dr. Hernandez. Somebody wants to do 33C and then 32B. So let's start with 32B.
let me create have my whiteboard here, ready to go. Can you guys see what I'm projecting here?
Yes, but just so you know, Professor, it says the whiteboard will not be recorded.
Where does it say that?
Oh, wow.
It says support for recording whiteboard is coming soon. I just wanted to let you know because I know you are recording this.
Well, thank you for pointing that out. I was not aware that. Wow. Where did you see that, though?
It
Did you
gave
get
me a
the answer, Priscilla?
notification up above the screen in Microsoft Teams.
Oh, I don't see it, but I'll take your word for it. But thank you for pointing it out.
Hmm.
Um, I don't know. I was not anticipating that. Oh, someone is saying I cannot see the whiteboard.
I can see the whiteboard, and I don't see the error message that you had seen earlier, the one about not recording. So
I
I
can see
don't
the
know.
whiteboard too. I
Yeah.
dismissed it. I hope that it didn't dismiss it on everybody's. I'm
Oh,
assuming it didn't.
let me dismiss the original one because the original message said that this was being recorded and that if you participate, it means that you're agreeing to that. But I don't see that the whiteboard isn't being recorded. Interesting.
Well, we have two ways to proceed. I can continue with a whiteboard, or I hate to do this to you, William.
Yes, sir.
If you can then work out the problems, maybe I can dictate or something. I don't
Sure.
know
That'll work.
how we can do this. We want to make sure that the students can see it. I see some Mr. Allman and Michael are saying that they cannot see the whiteboard. Can you guys let me know if you can see it now, or you still?
Yeah.
So we have some people commenting that they cannot. Some can see it and some cannot. That is
Yes. I can definitely do the problems with you, so I can write them out if you want to dictate the problems, Dr. Hernandez.
okay. I think it's because some of you signed as a guest, and
Yes.
that's the problem.
Yeah.
The ones that sign as a guest cannot see the board, whereas the ones that did not sign as a guest can see it. So we have a discrepancy here.
Oh, yes. So I can go ahead and I can share my
I am so
my
sorry.
tablet.
I
Oh,
was
you're
not
good.
anticipating this hiccup.
Oh, that's exactly, that's what happens whenever technology doesn't want to agree with us.
Yeah, that someone asked what we were using last time. That was OneNote.
Yeah, I use Microsoft OneNote whenever I do my notes online, and it's a Microsoft product, so it works with Microsoft pretty well. Awesome, guys. Well, we could do this. Not a problem. I have no problems doing math. This is what I do for fun.
Okay, let's see. We have, let me make a note of the questions that are coming up.
Sure.
33C, 32B.
Hmm.
Um, Somebody asking about 32C again.
Yep, we could do them. And let's see. Number 36 was also brought up. Okay.
Which one? Oh, 36, yes.
Okay. And we
36.
yeah,
You see, when we practice this, we can see each other's writing. So I was not anticipating that Teams will not be compatible with Whiteboard. But okay, 32B.
all right. And we could do this one right here. This is the integral
Okay.
of
When you have,
go ahead.
you want to go ahead and explain it, or
No, I'll let you
usually
explain
this
it.
is
I'll
an
just
integrand.
annotate.
Okay, remember the principle of integration is finding the function whose derivative is given. So basically in 32, for example, we're looking for the function whose derivative is the square root of x minus 1 over the square root of x. So it's an inverse operation to differentiation. So we have rules of integration just like we have rules of differentiation. In this case, we're looking for the integral of the square root of x minus 1 over the square root of x. When you have radicals in the integrand, which is what you call the function that you're integrating, when you have radicals, you want to convert those into rational exponents. So in this case, we're looking for the integral of x to the power 1/2 minus x to the power negative 1/2 close parenthesis dx. Okay, so basically now we're going to invoke the power rule for integration, which says that the integral of x to the n is equal to x to the n plus 1 over n plus 1 with one exception. And that exception is that n cannot be -1 because then the denominator will be 0. And we will look into when we look into chapter 5, we will see what happens when that n is -1. But for now in chapter 4, we deal with cases when n is not -1. So basically what you're going to do is apply this rule to this integral. Basically what you're going to do is break it out as a sum or difference of individual integrals. So we're going to find the integral of x to the 1/2 minus the integral of x to the -1/2. And then when we do those, we apply this rule. At the end, we're going to have a plus c, but we'll get into that in a minute. So now when we take x to the 1/2, the integral of x to the 1/2, we're going to have x to the 1/2 plus 1, which is x to the 3/2. And we're going to divide by 3/2 as well. And minus, then you're going to take x to the -1/2 plus 1, which is x to the 1 positive 1/2 over the 1/2 again. And then we're going to have a constant of integration plus capital C, which stands that maybe any function of that form where C is any real number will have that for the derivative. So basically what we have is what we call a general antiderivative, which is a family of curves. It's all functions that differ by a constant. And therefore they are all translations, vertical translations of each other. So in this, now we can rewrite this. The denominators can come up as coefficients as using the reciprocal. So you have 2/3 x to the 3/2 minus 2x to the 1/2 plus c. And in this case, because the original problem, you don't have to do this last step, guys. And when you're working in a final exam and your time is limited, maybe you want to look and leave this as the answer. But I usually tell my students, if the original problem was given in terms of radicals, maybe you want to express your answer in terms of radicals. So in this case, you're going to have 2/3 x times the square root of x. Simplifying the radical, it will be, okay, minus 2 square root of x plus c. But that first radical can be simplified as x square root of x. And that will be the simplified form of that radical. 2x square root of x over 3 minus 2 square root of x plus c. And that will be the answer to that problem. That was 32b. Let me check on 33c, which is the next one we had. Do you have it, Mike, William, or do you want me to dictate it?
Nope, I have it. I'll write it down here. It is the integral of 3 over u square roots of u plus 5u over 2 times the 5th u root of u to the 3rd plus 8. That whole quantity, take the antiderivative du.
Okay, so notice that the differential is du, which means we're integrating with respect to u, and the function is given all in terms of u. So u is our independent variable here. Again, we have cases of radicals, so basically what you're going to do is convert each of those radicals into rational exponents. In the first term, you have u square root of u. That basically is u times u to the 1/2 in that denominator, which becomes u to the 3/2 in the denominator, which comes up to u to the -3/2 at the top. Then you have 5 over 2, and now you're going to divide. You have u on the top and u to the 3/5 in the denominator, so you can subtract the exponents. Remember, u to the a over u to the b is u to the a minus b. So in this case, you have u over u to the 3/2. I'm sorry, to the 3/5. So you subtract u, 1 minus 3/5, you get 2/5 and 8. So now you apply the same rule that we did before. So you're going to have the 3, and you're going to have u to the -3/2 du plus 5/2. Remember, constants, constant coefficients you can pull out of the integral, an 8 integral of du. So now doing each of these, you get 3u to the negative 3 halves plus 1 over negative 3 halves plus 1. Negative 3 halves plus 1 is negative 1 half. So you're going to have 3u to negative 1 half, and you're going to divide that by negative 1 half, or dividing by negative 1 half is the same as multiplying by negative 2. And then the next term will be 5 halves.
Sorry.
And you have u to the 5th to the 2/5 plus 1, which is 2/5 plus 1. I'm sorry, hold on, I'm meeting someone from, that will be 7/5 and divided by 7/5. And then you have 8 and the integral of du, which is simply u. As a matter of fact, invisible is not written because it's implicit. In front of, in that last term, you have 8 integral of u to the 0 du, because we know u to the 0 is 1. So therefore, you can still apply the power rule and you say u to the 0 plus 1 over 0 plus 1, which is u to the first over 1, which is u, right? And then you can again simplify. You have the 3 over divided by negative 1 half, which is 3 times negative 2, which is a negative 6 for the first coefficient. For the second coefficient, you have 5 halves times 5 sevenths, so you have 25 over 14. And then you can, if you want, express the radicals, I'm sorry, express the rational exponents, the expressions involving rational exponents in terms of radicals. U to a negative 1 half is a square root of u in the denominator. And here we have 25 over 14, u to the 7/5. 7/5 is more than 1. So you're going to have an u, and then you're going to have u to the 2/5, or u, the 5th root of u squared. That's expressing it as a simplified radical, plus 8u plus c. Okay, so that will take care of problem 33C. The next one we were asked was number 36, I believe. Okay, in 36 is understanding the concept, verify the integration formula. And it's to verify that the integral of 2t sine of 2t dt equals negative t cosine of 2t plus 1/2 sine of 2t.
And they forgot a plus c, so I'm going to put that in there.
Yes. Okay, now in this case, this particular integral is one integral. Notice that the integrand has a product of two functions. It has a function 2t times the sine of 2t. These are two functions and it's a product. In order to do this integral using integration itself, you will need to invoke a technique that you have not learned yet. You learned this one in Calculus 2. It's called integration by parts. Now, notice that the question does not say to actually evaluate or perform the integral. It says verify the formula. So what we do is we kind of reverse engineer it. Basically what we're going to do, if the integral of the function is what you have on the right, then the derivative of what you have on the right should be the integrand of the integrand on the left. So basically all you have to do is show that the derivative of that function on the right, negative t cosine of 2t plus 1/2 sine of 2t plus c, show that that derivative is 2t times sine of 2t. If we show that that derivative, the derivative of that function on the right is what is inside that integral, we call the integrand on the left, then we have verified the formula. Because that's how integration works, is the reverse of differentiation. So now to do the integral, the derivative in the first term, we have to use the product rule, right? So in this case, we have the derivative of negative t. Not sure how you're going to write it. Plus 1, the derivative of the second term. And we have the derivative of a constant, but we know the derivative of a constant is 0, so that will basically vanish. So now to do the derivative in the first term, you need to use the product rule. And therefore you need to take the derivative of negative t times the function cosine of 2t, and then you take negative 2t times the derivative of cosine of 2t, basically applying the product rule. So you basically call your u and v. U is negative t, v is cosine of 2t, and then you do the derivatives of those two, and then you do one function times the derivative of the other. So you're going to have u times dv dt, or negative t. Which one are you writing?
Oh, I'm sorry. I did du dt times v first. So, but we can do the, yeah, we'll do the other one. So negative t times, sorry, negative 2 times the sine of 2t plus negative 1 times the cosine of 2t. There we go. Now we're on the right track.
Right, right. So basically that is the first one, negative t, times the derivative of the second one. The derivative of the cosine of 2t is a negative sine of 2t times 2. And then the derivative of the first one, which is negative 1, times the second function. Now we do the same thing with the second term, except the second term is not a product. So you have, it's just 1/2, and the derivative of sine of 2t. What's the derivative of sine? Cosine. So you apply the chain rule in that case. So you're going to have 1/2 times the derivative of sine, which is cosine of 2t, times the derivative of 2t, which is 2. And the 2's cancel, and all you have is cosine of 2t.
Boom. There we go. And there we go. We put it all together there.
Now they say to, let me see, they say to verify that is negative t cosine of 2t plus 1/2 sine of 2t. Is that what we have in the board? I'm trying to look at the problem and look at the board at the same time.
Yes. So what we did is we took the derivative of the right-hand side, and it came out to be the integrand, 2t times the sine of 2t, which is what we were expecting it to be.
Okay.
See, there's our integrand. Oh, sorry, guys. I tried to highlight that in blue, and it ended up putting a little mark on the paper. So give me just 1 second, guys. Every so often, Microsoft OneNote just takes a second to catch up with me. And so please forgive me, guys. I'm going to have to close it out for just a second, and I'm going to open it right back out. So please forgive me. It just sits there every so often and wants to give me a hard time. So I'm going to share it one more time. Just when you have so much information put on the same Microsoft OneNote, it wants to give you a hard time. So give me a second, and I apologize.
No problem. No problem. I'm taking notes of other exercises that they're asking while you're doing that. I see that somebody's asking about 34C and 35D. 34C and 35D.
Okay, and I'll write 34C right here.
We need to find a general solution to a differential. It's a simple differential equation.
Gosh, why did I write 2? That's a D. dy d theta is equal to 2 times theta minus, I'm going to just go ahead and write it as 2 times theta to the negative 1/2. There we go.
Okay, yeah, the original problem had 2 over the square root of theta. So basically what Professor Van der Steen wrote is that he converted the 2 over the square root of theta as 2 times theta to the power negative 1/2, which is equivalent, right? So basically in this case, it's what we call a separable differential equation, where you can separate the variables and all you have to do is integrate on both sides. So dy d theta, okay, that expression that we have on the left is not a quotient, is not a ratio. So you cannot, it's not really a fraction. dy d theta is actually a rate of change, but you can manipulate it in a similar fashion as if it was a fraction. So you can separate the variables, bring the d theta to the right. So now you have separated the variables. Notice now how we have all the y's on one side, all the thetas on the other side, and now all you have to do is integrate both sides of that equation. So the integral of dy equals the integral of 2 theta minus 2 theta to the power negative 1/2
There we go.
again, we are already splitting our integral in two different integrals because you separate the integrals that you have a sum or difference, then you convert it to a sum of difference of integrals. So now you integrate each of those. Now the integral of dy, again, that's like a y to the 0, is simply y, and you can introduce a c sub 1 there. Go ahead and write for me y plus c sub 1, because that integral is y plus a constant, right? Remember the integration of the integration and indefinite integral, and all of these are what we call indefinite integrals. What you have is what we call a general antiderivative that includes a constant of integration. On the right, you have 2 times the integral of theta, which using the power rule is theta to the 1 plus 1 over 1 plus 1, which is theta squared over 2, minus 2, and you have theta to the negative 1/2, so you have theta to the negative 1/2 plus 1 over the same amount, negative 1/2 plus 1, which is 1/2, right? And plus c sub 2, call it. That's a different constant. They don't have to be the same constants, right? So you have constants on both sides. So now what you have is y plus c1 equals theta squared minus 4 square root of theta plus c sub 2. Now to solve for y, all you have to do is bring the c1 to the right, and then you're going to have on the right c2 minus c1, but that's a difference of 2 constants, 2 arbitrary constants. So you can call that c. The difference of 2 constants is just a constant. So now you can call that just a plain c. So the solution, the general solution to the differential equation will be y equals theta squared minus 4 theta plus c. By the way, guys, many of you in the future may have to take a course called differential equations. This is sort of towards the beginning of that course, solving separable differential equations, which are the easier separate differential equations to solve. Okay. Somebody asked about, this was 34C, I believe.
Yes.
So somebody asked for 35D.
Ooh, got fun ones today.
And let me see, somebody's asking for 32C as well. Let's see. Okay, 35D consists of the integral of the cube root of 6x to the 4th minus 3x squared plus 2, all inside the cube root, times the expression negative 4x cubed plus x dx. Okay. Now, notice that in this integral, you have a cube root in this case, actually. You have a cube root function of another function. So if you look at that first expression on the left, let me wait until he finishes.
There you go. I'm sorry. I'm just rewriting it for you.
Yeah, let me just explain something here. If you look at that first expression on the left, you have a cube root of 6x to the 4th minus 3x squared plus 2. First, I notice how that is what we call a composite function. It's a composite function. It's a function of a function. You have the cube root of an inner function, in this case 6x to the 4th minus 3x squared plus 2. If you were to differentiate that radical, if the question was find the derivative of the cube root of 6x 4th minus 3x squared plus 2, I hope you agree with me, you will have to use the chain rule because you have a composite function, a function of a function. But in this case, we're integrating that. And in this case, the reverse form of integration that you use when you have the integral of a composite function is integration by u substitution, by substitution, which is in section, I believe, 4.5 in the chapter 4. In this case, though, we call that inner function 6x to the fourth minus 3x squared plus 2. We need to verify we have the derivative of that inner function except for maybe a constant factor. We need to have that derivative except for maybe a constant factor. So what we do is we're checking if we can do substitution, if substitution will work. It may not work. We don't know that for a fact yet. So we call u equal to 6x to the fourth minus 3x squared plus 2, and then we find the derivative of that. And the derivative of that is 24x cubed minus 6x. So you can now scratch the dx in the bottom on the left.
Oh, yeah, sorry.
Okay.
Yeah, I'm
Okay.
sorry. I'm doing it, kind of doing steps at a time here.
That's fine. That's fine. That's fine. I appreciate you doing this. Okay. Notice that we can factor a 6, common factor out of that, and we get a 6, in this case a negative 6. Because what are we trying to do, guys? We're trying to see if that negative 4x cubed plus x, look at the yellow. We need to see if that negative 4x cubed plus x is the derivative of that inner function, 6x to the fourth minus 3x squared plus 2, except for maybe a constant. Okay? And in that case, by factoring that negative 6 out of that derivative, we have the negative 6 times the negative 4x cubed plus x dx, which is exactly what we have in the yellow part. So now the original problem does not have that negative 6, but we can always multiply and divide by a constant. Multiply and dividing by a constant is like multiplying by 1. So you're not altering the expression. So what we're going to do is multiply by negative 6 and divide by negative 6 as well. So basically what we're doing is effectively multiplying by a 1. The negative 6 we're going to leave inside the integral, because together with the negative 4x cubed plus x is the derivative of the inner function, and the negative 1/6 we're going to pull outside. So notice what he has in yellow is what was the derivative of the inner function, and the negative 6 is an artifice that we've created to have that negative 4x cubed plus x, and we divided by the negative 6 to cancel it. So now we have u to the 1/3 du. Any questions on that so far? Let me stop there. Any questions on that? On what we've done so far?
No.
Okay, good. So now we can proceed, and basically now what we have to say, what we have to do is integrate using the power rule, the u to the n plus 1 over n plus 1 plus c, right? So we're going to have the negative 1/6, and then we're going to have u to the 1/3 plus 1, which is 4/3 divided by 4/3, the same amount, and a plus c. And then now we can simplify the expression. We have the negative 1/6 times the 3/4, and then we have u to the 4/3 plus c. Now remember, u was something we created. The original problem was in terms of x. We called something else u, but the original problem was in terms of x. So you always need to go back when you use substitution and go back to rewrite your derivative, your integral, excuse me, in terms of the original variable in this case. So we have to replace u with what it was. In this case, u was 6x to the fourth minus 3x squared plus 2. And if you want to write that as a simplified radical, you can say negative 1/8, and then you have the whole polynomial 6x to the fourth minus 3x squared plus 2 times the cube root of that. That's because 4/3 is 1 plus 1/3. and then plus c. And that is that integration. Okay, which one was this? This was
35 part D.
35D. So somebody asked 32C earlier.
Yes.
What is 32C? Let me go back and look at it. 32C. Okay, it's the integral of secant of alpha tangent of alpha minus sine of alpha d alpha. So in this case, the variable is alpha. Okay, cool. Okay, now remember, once again, integration is the reverse of differentiation. So what you need to think is, do we know a function whose derivative is secant tangent? And we do know a function whose derivative is secant tangent, and that is secant. The derivative of secant is secant tangent.
Just writing that out here.
That's right. So in this case, we just reverse that and rewrite it in terms of alpha. So the integration, the first part of the integral will be just secant of alpha minus then the integral of sine of alpha. What function has for sine as derivative? Well, the derivative of cosine is negative sine. So that means that the derivative of negative cosine will be positive sine. So you're going to have the integral of sine is negative cosine, and then the negatives cancel each other. So your final answer will be secant of alpha plus cosine of alpha plus c. Don't forget that plus c, guys. Okay, whenever you have an indefinite integral, you must include that plus c at the end to make it correct. That means you have technically infinitely many possible functions whose derivative is given, and they'll differ by a constant. So they're what we call a family of curves. Okay, I don't see any other questions, and we are at 11:27. So
Yes.
we're almost out of time, but I want to work some from the transcendental functions from chapter 5 before we dismiss the review. This starts with questions number 40 and goes all the way to 77. There's a lot of those, starting with question number 40. Any questions on those? We have time to maybe do 2 or 3 of those, because we are approaching the end of this session. Okay, somebody's asked for 47 and 60. Let's work on those two. Those are the first to be asked. That might be the time we have. 47. Let's see, 47. You got it, William?
Yep. Wrote it up there for you, sir.
Okay. Is the derivative of 3 ln of the absolute value of sine of x. Okay. Now, guys, what is the derivative of ln of u? The derivative of ln of u is 1 over u times u prime, right? That first equal sign, go ahead and erase that.
Oh, yeah. Sorry.
Yeah, that's
Sorry
okay.
about that.
Okay. Now, the difference, the absolute value really makes no difference other than in the domain of the function. Go ahead and write for me the derivative of ln of u without the absolute value.
Okay. So the
derivative d du of just ln of u is also 1 over u prime. What's the difference here? Notice you have whether you have the absolute value or not. It's not making really any difference, but it is. The difference is the domain. In the first one, where you have the absolute value, u could be anything, any real number except for 0. So the domain in the first case, u could be any real number, so that except is can be, wait,
Oh, sorry, x cannot equal to 0.
x cannot be equal to 0, correct. However, in the second one, the domain is strictly positive values for u. You can only take positive values. In the first one, u could be any real number but 0 in the second. So you see, that's the only difference the absolute value makes. But other than that, the derivative is the same. So in this case, for h of x being 3 ln of absolute value of sine of x, the derivative, again, you have a 3 constant, so that will be a factor of 3 in the derivative. And then you're going to have the derivative of ln of sine of x, absolute value of sine of x, will be 1 over sine of x. And then you can multiply times the derivative chain rule, right, of sine of x, which is cosine of x. And then you can rewrite this as 3 times the cotangent of x. Actually, it should be u. Oh, wait. Never mind. Yeah, it's x. In the original problem, u was my formulas. Yes, it's in terms of x. Notice that in this case, you have a restriction in the domain where x cannot be anything that makes this what sine is equal to 0, because cotangent is not defined when sine is 0. Okay. Okay, let's see. Which one was 47? We have 60 and 60. Okay, one student, Shelby, you wrote 1 over u. I'm not sure what you were referring to.
You were just asking what the derivative of L in U was,
Oh,
and I got in class mode and sorry.
See, unfortunately, in the classroom, we love that kind of participation when the student actually precedes our answer, right? When you guys give us our answer, that's great. Unfortunately, when we get doing this, it's hard to follow the chat while also at the same time making the presentation. Okay, so which one is this? Number 60. Okay,
yes,
so
sir.
we have the integral of 5 pi cotangent of theta plus 3 cosecant of theta. Okay, let's break this in parts. The first one, you have the 5 pi integral of cotangent of theta, d theta. And the second one, you have the cosecant of theta, d theta. Okay, now we have found formulas. Remember, cosine, cotangent is cosine over sine. So you don't need to write all of this, Michael. I just want to go real quick over how do we find the integral of cotangent. I'm sorry, William.
That's okay.
Cotangent of theta is cosine over sine. So what you could do when you're doing that integral of cotangent of theta is use a small substitution. Let u be sine, and the derivative of sine, which is in the denominator of cotangent. Thank you. Yes, that's. No, it's the other way around. Cotangent is cosine over sine.
Thank you. Sorry. Yep. Got into robot mode there.
Right.
There we go.
And now you can use a little substitution. U is sine of theta, and then the derivative of sine du is cosine of theta d theta. And basically, all you have is cotangent of theta d theta is basically the integral of 1 over u du if you use that substitution, which would be the natural log of the absolute value of sine of theta. And that will be the integral for the cotangent of theta. Okay? Now for the next one, you have 3 times the integral, and we can take the cosecant to the right in the margin. Okay. We can work the cosecant on the margin. This one involves a little trick. Okay, to find the integral of cosecant, what you're going to do is multiply cosecant times the expression cosecant plus cotangent over cosecant plus cotangent.
Okay, sorry about that. I'm just going to write it over here in red, and I apologize. Cosecant theta plus cotangent theta over cosecant theta plus cotangent theta. There we go.
Correct. And when you expand that numerator, you get cosecant squared plus cosecant times cotangent.
I better do it underneath it. Sorry.
Yeah, that's fine.
Okay. Yeah. Cosecant squared theta plus cosecant theta times cotangent theta. Okay.
Over the cosecant theta plus the cotangent theta. Now, guys, what do you notice? What's the derivative of cosecant? Cosecant to cotangent. It's the opposite, right? The derivative of cosecant, it will be a negative cosecant times cotangent. What's the derivative of cotangent? It will be a negative cosecant squared. So what do you have on the top? On the top you have the negative derivative, the opposite of the derivative of the denominator. So if you make an u equal to cosecant of theta plus cotangent of theta, that's the u in the denominator, the numerator will be the opposite of the du. You don't have any negatives there, so therefore what you have is the opposite. So now we can go back to our integral, and we have the integral of cosecant d theta will be the negative du over u, provided in this case that u is cosecant plus cotangent. So what is the integral of that? That will be plus 3. The second term will be plus 3, and then you have ln.
Well, we got that negative sign to deal with, right?
Right.
There we go.
Yeah. Of the absolute value of cosecant plus cotangent. And I was going to say that that negative you can bring up as an exponent. That's why I didn't mention.
Yep.
Because you can say that's ln of cosecant plus cotangent to the power -1 instead of writing the negative in front. Or either way, guys, you can write it as -3.
So we can write it like this: cosecant theta plus cotangent theta, that raised to the -1 power.
To negative, the negative will be outside the absolute value.
Oh, yeah,
right?
sorry. Yep.
It's a power. Or that negative could multiply the 3 and make that second term a -3 ln of the absolute value of cosecant of theta plus cotangent of theta. Either way is correct. You need still that plus c. Remember, these are all indefinite integrals. We can do 73 as the last one. Personally, I will need to go, and Professor van der Zijden, if you want to stay,